Guys, okay, I'm gonna do chapter 3 now. Okay, so the first question says, give an example of the value b for which f of x equals b over 5 raised to the x represents exponential growth. In order to have exponential growth, remember this number here, your base had to be greater than 1. So it's b over 5. So it can't be 5 over 5 because that would equal 1. All right, so it has to be greater than 5. Okay, so b has to be greater than 5. If it was 6, if it was 7, if it was 8, any of those would be a whole number and would make this be exponential growth. Okay, it says to graph this with the graphing calculator with this window and answer these questions, but we kind of can answer most of these questions without graphing it. All right, so we have a fraction, which is normally decay that looks like this, but it's being flipped over the x-axis like that. It's being shifted up 4 units and over to the left 1. So it's kind of like something like this. All right, we can answer the domain because the domain on every exponential, I don't care what the exponential is negative infinity to positive infinity. The range goes from negative infinity up to the asymptote. This is your asymptote, okay? And we could actually put that in. Your asymptote is y equals 4, and the range is from negative infinity to the asymptote. Your y-intercept, to find the y-intercept, we make x equals 0. So if I make x equals 0, I have negative 1/3, 0 plus 1. So negative 1/3 raised to the first power is negative 1/3 plus 4. I'm going to change 4 to 12 over 3. Why? Because 12 over 3 equals 4. And now they have common denominators, so my y-intercept is 11 over 3. End behavior, if you look at this graph, the end behavior, the limit as x goes to negative infinity, this graph is going down towards negative infinity. The limit as x goes to positive infinity, as we go to the right, this graph is approaching an asymptote. F of x equals 4. The graph is increasing over the whole domain. It is not decreasing at all. So I really don't think we needed to even throw that into the graphing calculator. All right, so they want to know what happened here as far as transformations. This negative means that it was reflected over the x, not the y. The y would have been in the function. Remember, why is there a negative in my house? 2/3 is also outside. So it's a vertical, you hear me? I'm tired. It's a vertical compression of 2/3 or shrinking. And this negative 1 means we move it to the right 1. Over here, the transformations that happen, now see the negative is in the house, so it's a reflection over y. 2/3 is in the house. Okay, so now when you multiply something by a fraction, you would think it gets smaller, but it's in the house. It's a horror show. So it is a horizontal stretching or expanding, however you want to do that, by, remember you flip that, 3/2, and this is down 1. Okay, we're going to expand this, so I'm going to need some notebook paper here. So we have log base 13 of 3x to the 4th over the cube root of 7x minus 3. First, guys, whenever you see a root, you have to change that exponent. Rewrite this as log base 13, 3x4 over, it's 7x minus 3 raised to the 1/3. Remember, it's a fractional exponent. Okay? Now, when we want to expand this, we have to see how many components there are. There's a 3, there's an x to the 4th, and there's a 7x minus 3. So that means we're going to write log base 13 3 times. Log base 13 of 3. It's still in the numerator, so it's positive. That 4 goes in front. 4 log base 13 of x, and this is in the denominator, minus 1/3 log base 13 of 7x minus 3. So that's it expanded. And they want to condense this. Remember, to condense, just look to see what the sign is. This is positive, so it's going to be in the numerator. This is negative, it's going to be in the denominator. This is positive, the numerator. These are the exponents. 1/2 means it's going to translate back to a square root. So it's the ln of x squared over a to the 7th. This is positive, so it's the square root of b. Okay, write this in exponential form. What's your base? Your base is e to the 5th equals x. Write this in log. It's log base 8 of 16 equals 4/3. Look in your notes, guys. That's just an actual formula back and forth. Okay, to do some of these, to simplify, some are really easy, guys. E raised to the ln cancels out, the answer is 7. 5 log 5 cancels out, the answer is 3. 10 raised to some power equals 1. Well, anything raised to the 0 power is 1. Okay, let's rewrite this. 2 to some power equals 1 over 32. Well, we make them the same bases, remember? 2 to the x equals, 32 is really 2 to the 5th power. Bring it up, 2 to the negative 5. Bases are the same, x equal negative 5. You're 1 to 1. Same thing here. It's 3 to the 1/2. See how I changed that square root to 1/2? Okay. Raised to the x power equals 3 to the 1 power. Bases are the same. So it's 1/2 x equals 1, x equals 2. Okay. Here, all right. I'm trying to think if the quickest way is to condense this one or to show it to you separately. I think it might be easier to show it to you separately. This goes in front, so this would be 21 because ln e cancels out. Technically, this is, I'm going to write it here, ln e to the negative 2. This cancels out, so this is negative 2, and that's why this is 19. Okay, the rest I'm going to have to do on paper. So let me get some notebook paper. If your chapter 3 doesn't look like this chapter 3, it's because I tried to condense the one page together so that I can see all the problems together. Okay, so 15. 25 to the 3x plus 2 equals 125 to the x plus 1. Make the bases the same. They both can be written as bases of 5. So this is 5 squared, 3x plus 2 equals 5 cubed, x plus 1. When that's the same, guys, this cancels out, and now you just set the exponents, equal it to each other. So this would be 6x plus 4 equals 3x plus 3. 3x equals negative 1, x equals negative 1/3. Okay, let's look at number 16. So I have 5 times 3 to the x minus 1 equals 20. Divide both sides by 5. Remember, we need to isolate that base. So I get 3 x minus 1 equals 4. Take the log on both sides because you can't make these into the same base. Okay, so we'll do x minus 1 because the exponent goes first, log 3 equals log 4. We're trying to get x alone, so we'll divide both sides by log 3. So it's x minus 1 equals log 4 divided by log 3, and then we'll just bring the 1 over, and then you throw this in the calculator. Remember, your calculator can do it because your base is 10. All right, and I think the answer is x equal 2.262. Okay, 17, 2 e raised to the x plus 3 plus 4 equals 34. All right, we'll bring the 4 over to get 30 and divide it by 2. So now we have e to the x plus 3. Remember, we have to isolate this. So I subtracted and divided is 15. Now because it's e, I'm going to take the ln on both sides. So it's x plus 3 ln e equals ln 15. ln e is gone. Okay, that equals 1. So now I have x plus 3 equals ln 15. I need to get that x alone, so I'll bring it to the other side. X equals ln of 15 minus 3. X equals negative 0.292. Okay, and that's a calculator one. All right, let's look at number 18. Log 3x plus 1 equals 2. Okay, so we've isolated the log. All right, so we don't have to move anything or combine anything. We just have to exponentiate. Your base is 10. 10 to the log cancels out. 10 to the 2 is 100. We're left with 3x plus 1 equals 100. 3x equals 99. X equals 33. Number 19, I have log base 8 of x plus 11. I'm sorry, x squared plus 11 equals log, I said 8, but I wrote 3. I don't know why. Log base 8 of 92. Now see the difference between this and this? This only had one log. That's why immediately we went to exponentiate. When you can do that when you have one log and you have a number. Here we just have two numbers at the same. Guys, 1 to 1. This is an easy one. X squared plus 11 equals 92. X squared equals 81. X equals plus or minus 9. Remember to check. Okay, I didn't check here though, but 33 when I plug it in gives me a positive number. When I put a negative in here and I square it, it's going to be positive, so you're fine with both. Now, the next one, 20, has ln of 2x plus 1 plus ln of x plus 1 equals ln of 13 minus, 2x. See how this was a 1 to 1? This is not a 1 to 1 yet because it's not 1 to 1. It's 2 to 1. So we'll combine these. ln of 2x plus 1 times x plus 1 equals ln of 13 minus 2x. Now it's 1 to 1. Now we just have a regular algebraic problem. I would FOIL this out to get 2x squared, that's 2x, and 1x is 3x plus 1 equals 13 minus 2x. I'll bring everything to the right side. To the left side. Minus 13. So we have 2x squared plus 5x minus 12 equals 0. Okay. We can factor that. I'll do my little trick. So I have x squared plus 5x minus 24, x minus 8, x plus 8, x minus 3. So it's x plus 4. And put the 2 there. 2x minus 3 equals 0. So I have x equal negative 4, x equals 3 halves. However, when I check it, when I put a negative 4 into here or into here, I'm going to have a negative value. I can't have that. So this is extraneous, and the answer is going to be 3 over 2. Okay. Now the last one, all right, it can't be 1 to 1 because we still have a number by itself. But what I can do is I could bring this to the other side and put it together. So I'll have log base 2 of x plus 4 minus log base 2 of x minus 3 equals 3. I'm going to put this together and get log base 2 of x plus 4 over x minus 3 equals 3. Okay, because it was subtraction, it's division. Now I'm going to exponentiate 2. So I have x plus 4, x minus 3 equals 8. 2 to the third is 8. I'll multiply both sides by x minus 3. So I have x plus 4 equals 8x minus 24. So I'll have 7x equals 28, x equals 4. Okay, so if I substitute in this positive and this is positive, so it's not an extraneous root. Okay, between which two integers does the value of log base 2 of 53 lie? So what this question is basically asking, okay, is 2 to what power? So if I, like 2 to some power equals 53, you know that's not true. But I know that 2 to the 5th power is 2 times 2, 4, 8, 16, 32. And I know 2 to the 6th power is 64, and 53 is between that, so it's between 5 and 6. That's all that's asking, to understand that you know that. Okay. We actually are going to skip these problems. Okay, these word problems. This one is actually wrong on the answer sheet. Okay, so we're just not even going to do that. And that actually takes care of chapter 3.